Now that we're done dimensioning stock, we're coming back and we're drilling. And I'm double checking all my values. So first I find my reference corner, and then all measurements are based off that. And I'm going to mark the corners so I can come back to it so I know which one's my reference that I based everything off of. All right, so I'm going to find my zeros. So I go until it just starts to read, then back off a little till it flickers where I'm making intermittent contact. And that will be my X0, except that we need to go over 100 thousandths to compensate for the 200 thousandths diameter of the measuring probe. Zero my DRO off for that. And I can use my parallel here anywhere to find my next zero. There we go, there's Y0. And we got to go over 100 thousandths and 0. So now when I'm at 0, 0, that'll be right over this corner back here, which is my reference surface where I put my dot. So next up, I'm just going to drill some holes. I've got my first position here, but material costs are such that I have been double checking. So I just drop the drill bit, put a little mark, make sure that I'm the 1/4 inch I'm supposed to be that way, and 2.25 this way, which I am. So I'm just double checking because material is expensive enough and it takes enough time to get it all dimensioned, everything, that I really don't want to screw it up. Next up, we're just drilling some holes. I'm using some anchor lube that Stan Zinkowski sells, and it works really good for machining. Works particularly well on stainless, but using it here on aluminum works great too. And it gets used up in the cutting process, so you don't end up with a big mess, which is really nice. First one. Got to move my clamp for the next one. By the way, you're seeing an example where these quick clamps come in really handy. I don't have to slide a T-nut all the way off the end. I just pop them into the new slot. You just twist them out. They come up straight, go down, lock in. I've been using them this whole time because they make for really quick setup changes when you have to. And if you don't need to really riff on a part, which I don't, since we're just drilling, easy, low pressure operation. Now we're going to power this guy up, and it's already at the fastest speed, which is going to be the heaviest load of my variable frequency drive. Right here. And finding the side is tough, so I just grabbed some Dicom, and well, tough's not the word, just struggle to find it each time, usually 50-50, 100% wrong, so I get the wrong side, and that one doesn't fit, so Dicom, and easy to find. Just a little trick to speed things up when you're constantly taking things in and out. We're on to the back piece, which is pretty large, 24.5 by 12. So drilling it's going to be challenging because the lathe barely the mill barely makes it to the Y dimension here. I mean, we can get there, but it's tight. So the first go around on the really large piece, I screwed up. So the second time, I'm putting layout lines because I was uncareful and it was really late at night. I was really tired, so I should have stopped, but I didn't. And that cost me $70 because that's how much this piece cost. I mean, I'll have most of the piece that's still useful, but there really isn't much of a good excuse. So this time, I'm laying out all the marks, putting the measurements on here so I can just hit them really quickly. So I'm going to redo this piece and we'll be right back. Alrighty, so we're ready to work on our next part, and this is just drilling a few holes and putting a relief pocket in the middle. And from the outside of the BeltSander, it looks like this, and this actually is a hidden line because that pocket is on the other side. So to make it so I could do it all from one side, I basically mirror image this part because it's not symmetrical. And now I can do the pocket and the holes without flipping the part over and re-finding my zero. I even took the same corner that I'm using as my identity corner, just the back side, and flip this around and use the same side on the other side. So we're going to drill 4 holes and we're going to come into the pocket. The pocket, in case you're wondering, is relief because this gear actually is going to be inset into this plate a bit, just because that's how things fit. So let's get started. All right, I'm going to drill the next 3 holes. I'll bring you back. All right, so we're just going to mill out a pocket, and we're not going to go all the way through. So we're looking for a total depth of 0.460. We'll save the last 10 thousandths for a final pass. So we'll do 450. Now we want to traverse side to side, 1.1 inches. Sounds like there's a little fast. Let's go a little slower. Alrighty, another part done. Next one coming up. Alright, so the next piece we have here is one of the most essential pieces. It's sort of the spine of the whole thing, and all the other pieces sort of mate to this one. That's why it's 3/4 of an inch. The main drive motor shaft goes through down below, and also up here the tightening adjust for the belt tension. So we're going to be drilling some 1/4 inch holes through it, and I'm using anchor lube, which has been really good for drilling. Doesn't leave a lot of mess around, and it prevents chip welding, which there's some chips on here because the last time I didn't use it. Anyways, so we're gonna move right ahead, and you've seen a lot of drilling, so I'm just gonna skip right ahead. All right, so we pre-drilled this hole right over here. Let me zoom you in there a little bit. Okay, and basically this hole needs to be enlarged to 3/4. Right on the money, 750. We want it to be 1,000th because this guy is going to be a press fit in here. So what I'm going to do is I'm going to start with this 11/16 end mill that I have. It's an inexpensive high-speed steel end mill, and we're going to hog out most of the material this way and then go with the boring bar for the last 16th, and that'll speed things up. Alrighty, we are through. By the way, I find these really handy. This is a really inexpensive Chinese set of end mills. They're titanium nitride coated high-speed steel bits, and I use them only for approximate hole cutting, basically to remove excess material. But they're spaced, sizing-wise every 16th, which lets you get really close. What I did find is that the accuracy of the diameter is really poor, so the holes they bore are oversized every time. And so you can't do anything precision with them, but when you need to remove a lot of material, they're really handy tool set to have, and they're fairly inexpensive. So I use these all the time. I really like them. Again, the quality's not great, although the hole quality in here is pretty darn good. All right, so we got the boring head here, and we start by finding the edge of this guy in here. And I've replaced the insert this time with an aluminum cutting insert, so I should get a better surface finish. So this is about 0, and we need to go in 62 thousandths total. So I think we will shoot for another 40 the first go around, and then we'll walk it in. So I'm dialing in another 40, and I'll tighten this guy. There we go. And I need to slow this guy down to a couple hundred RPM. Let's speed this up just a little. Okay. Do a little bit of measurement, find out how far we need to go. Last pass taking off 3 thousandths. Sped things up just a little bit. Fortunately, this is a press fit and not something that the surface finish will matter at all. Oh yeah, that's going to start. Can't use the flat of the boring bar. See how that works. We'll try it gently. Yeah, easy peasy. Very nice. Okay. So bushing is in. One more hole for the bearing to go, and that's down over there. We're working on the bearing seat for the drive shaft here, so there's a 0.5 inch through hole, which you can't see at this angle, and then I did a three-quarter inch end mill to remove most of the material to save me having to spend too much time on the boring bar. And I'm going to do boring next. So I figured out what killed the surface finish. This is still a manual feed right here. It was this cutter thickness, even though it's thinner than the one I took out, this aluminum one. The back relief is such that the rear of the cutter was dragging at the small diameter hole, and that was my problem. So in order to fix that, I would have to take this and grind off the back of it just a little bit. Interesting observation. Should have been more careful. It's a novice mistake that anyone who does high-speed steel or something like that would immediately recognize, because they're always compensating for it. People that use carbide cutters, we don't think about it because the cutter's pre-done for you, and easy mistake to make. Alright, so you can see this thing just starts where the chamfer is and then gets snug. So we will press this in later because we don't want the bearings exposed to all the chips that are going to be produced, because I'm not done with this piece yet. Still have to drill and tap holes in the sides. Alright, next up I've got several of these pieces to make. There's 3 pieces that have drilled and tapped holes. These currently show pinned holes, but I think I'm going to switch to tapped holes. I don't think I need the extra stability pins would give me, and it'll give me a little latitude for motion. So these are going to get 11 drilled and tapped holes. 2 of those plus, flip this guy up here. You got this big guy right here that's got a ton of tapped holes going all the way down. That's one we did the big holes in already, but now I need to drill and tap along the edges. So what I want to use is my Chinese-made tapping head here. It would be nice to have a Tapmatic, but we do not. So we're going to try and make this one work. So I made some adapters for it here, which I'll show you in a bit. This bar goes in the bar of the mill here because it needs a stop, and then this pin was part of its original pin, which I cut shorter, and then there's this brass piece that'll be floating up and down this bar as it stopped for the torque adjustment. So what we're going to do here is I've got loaded in the mill a piece of stock that is identical to what I'm going to do, be cutting on, and we're going to do a test to find where the torque adjustment should be on this guy. Hopefully we won't do any major damage. Next up, I've loaded the tapping head, and on one side here, if you can see, it's got basically the amount of force before the tap releases and reverses. So first I need to get this guy, and I need to load the pin in here. This is that short little pin I was talking about. Now this side is captive. The other side is just gonna be loose. It's just floating. So this guy here is just gonna float like so. I take this rod here, which I made out of stainless, pop it in here, and now we just need to lower this guy down far enough to get this guy started here. There we go, and we're good to go. So if you can see it now, it's captive. Let me take you off here. So it floats, it can't fall out, but it will stop and allow the torque release to engage, hopefully. So what we're going to do is we're going to start with the lightest, setting up here at 1. And I think this thing's full capacity is 1/4 inch, so we're going to see if I need to go all the way to 4 to make it work. But what we don't want to do is break the tap, and since these are blind bottom holes, meaning I need to jack the chips up, these kind of taps, rather than, these are spiral flute. Spiral point taps are a little bit beefier web in the middle because they don't have to eject, they push the chips forward. So these are a little bit weaker. So let's hope I don't break it. Let's just give this guy a shot. I think I need to bring my table up a bit. There we go. So let's see how this works. Okay, already released. Got to tighten that up. I figured as much. We were going to start gentle. So we'll go to 2 here. We're using ankle lube again. Okay, that looks like it went down almost all the way, so a little bit tighter. Got to move over one here, clean off the chips. Alrighty. I don't think that's quite making it all the way to the bottom. Perfect. I think we're good. Well, we have success, and I just want to point out that I am not using an inexpensive tap. This is an Emuge made in Germany, and I don't recommend trying this with a inexpensive tap unless you want to have a greater chance of having a tap break off in your part. So this was a success, so I'm going to try and make those other parts using the Asian ripoff Tapmatic clone. And that should speed things up a lot. It seems like we're working pretty well here. Let's see the last one here. Yep, that looks like pretty much full depth. So I think we're good to go. On to the real parts. All right, so we're set up here to drill and tap the plates that need drilling and tapping. The first one is a pair of plates right here, and they're identical. And the holes are symmetrical on either side, so I've set my 0 based on this stop, and I'm going to drill the first hole. I'm going to flip it 180, drill the second hole, flip it back. I could rotate this other way and drill that hole as well because it's perfectly symmetrical, but I may not trust that because everything's going to be referenced off of one side. So I've been doing that the whole time, so I'm probably going to stick with that, just in case I did some really silly mistake. Hopefully things will still go together and I can salvage a screw up. So we're going to drill and tap. First we're going to drill all of them, then we're going to come back and tap. One thing that's important to note is that it's important to flip the part like this, not like this. Because if you do that, then your reference point becomes the opposite side. All right, so that was the last hole this side. And just so you know, doing all 2 sides of both pieces took about 10 minutes is all. Next we're going to set up for the Tapmatic, and we're going to go for that. All right, so we're set up with the Tapmatic, or the rip-off Tapmatic, and we're going to start at the last hole we worked on. We are going to go to back gear for this to go slower, and gotta get some good amount of lube on here. This ankle lube's been working really well. So okay, one down. That worked pretty well. I panicked and I turned off the quill, the quill motor, because I was worried that it hit the bottom, because it did put a fair amount of torque on this, but I guess that makes sense. Wow. Wow, it actually bent it a little bit. That's a ton of force. I guess way down here, that's what's going to happen. That's interesting. Maybe I shouldn't have used stainless steel for that. So we just tried one with my normal lube, which is Cool Tool 2. And I think it does a little bit better than the Anchor lube in this. I'm not sure. For one thing, the chips don't stick to it as much. The Anchor lube, if you put a lot of it on, the chips tend to stick to the tool a lot more and they're harder to clean off. So maybe this is a plus. Anyways, I'm going to try the last few of these with Cool Tool 2, which is my regular cutting fluid. Well, this next setup, trying to drill the holes on end. I don't have a drill press. I've been using my mill to do that because I don't have room for a drill press. So getting this is going to be fun. So we're using an angle clamp and some cant twist to hold it to the angle. I did indicate the angle stock in so that as I traverse on the x-axis, it's not going to shift one way or the other. It's within 0.5 over a foot, so that's pretty darn good. I'm at the sort of extremes of everything. I really need a riser for my mill because I will not be able to do the tapping on here. These are all going to have to be hand tapped. Anyway, so we're going to do these 3 holes on this end, and then I'm going to take the piece out. I've got my 0 set based on this, but it's not worth flipping because I got the cant twist clamps in here and everything. So we're just going to do this, and I'll bring you back when it's done. Alrighty, here's the case as it stands now. The back's not so terribly exciting. The side here, this is going to have a handle to allow me to tighten the tension on the belt. Down here, the shaft for the pulley will come out for the drive motor, which will be back or below. It all went together pretty smoothly except for a little screw up over here. And I couldn't figure out what was going on because I measured very carefully and repeated my measurements several times and still got a taper in the positioning of my holes. And I discovered what happens that my rule that I was using as my reference surface was not parallel to the ways of the mill. And why, you ask? Well, turns out it's this guy, this electronic edge finder that I love so much because it makes things really easy to use, has a major flaw. The shaft that it's built on is aluminum, and there's a slight bit of insulator between the aluminum and the conductive tip. And so if you touch off too hard, it deforms. I threw an indicator on this in the spindle, and I was getting almost 16 thousandths of run out. So this thing was way off. So if it rotated even a little bit while you're touching off a part, or you touch off a part on this side for this one, and then touch off on this side for this one, they're not going to be the same, and because it's bent. And so I took it to the lathe and I turned it back down so that it was round again. Now instead of 100 thousandths coming off, it's 85 thousandths you subtract. But I don't know if I'll trust this guy again. The good old rotary edge finders don't have that problem. You bump them and they're designed specifically to move and not be damaged by it. So you can't touch off. I mean, you could touch off too hard if you really went crazy, but in normal operation, that'll never happen. So the old timers are probably laughing saying, see, I told you, the good old fashioned ways are great. And you know what? They're right. So I've gone back to using the rotary edge finder. I don't know that I will replace this with a new one. I mean, they are really convenient, but you have to constantly test them to make sure that you haven't bent it. This piece here goes right behind here and will be the backing plate for the belt. On top of that will be a piece of spring steel. On the top of it, this slot here is for the gear that allows you to tighten the belt. This piece right here goes this way. The shaft for the belt tightening mechanism goes in there, and down at the bottom you can see the pulley for the motor, or hopefully you can see the pulley for the motor. On that side and on that side there are bearings pressed in, and the pulley goes through for the bottom drive drum. So that's pretty much it, and I'm more or less happy. I'm a little disappointed about the taper here. I might open these holes up a little so I can slop it around. There's no precision measurements that are going to come off of that, but the fact that that's there really bothers me. So anyways, I learned a lot, and hopefully I'll see you in the next part coming up. I don't know what part number that is because I'm breaking this up as I go, and it depends on how long they are. I'm trying to keep the videos manageable lengths. So anyways, thanks for watching. Hope you find it useful. Hope to see you next time.